This is an abbreviated version of a presentation I gave at the Zero Emission Building Conference, How to Sell a High Performance Home. And my approach to this was to basically say, it's different now. There are all these factors that are affecting us and people's impressions of what a high performance home might be. We've got issues from the coronavirus to the increasing heating of our environment, the heat waves that they had this summer, and of course the circumstances that were happening at the time I did this presentation, which because of those heat waves and droughts, fires like we've never seen before. Now I looked, because this presentation was in British Columbia and I am in Toronto, I wanted to get a handle of what do they out west consider a high performance home. And there was this guide from BC Housing, and it showed a house with 3 garages that sure didn't look like a high performance home to me. And I really wondered what would make BC Housing pick a luxury home exterior with green grass and driveway at sunset as the poster child for the cover of their guide. And I think it's because, frankly, that's what they think people want to see in a home, and I don't believe they're wrong. High-performance homes are a funny thing. People immediately think of energy, and the main reason they would invest in them is, they say, 59% to save money. If you look at the term high-performance home in this survey by the Shelton Group, you see it's way down second from the bottom. To have a high-performance home is only 18%. The only thing it beats is that clearly unimportant to preserve the quality of life for future generations. And the point is, nobody is going to invest in a high-performance home these days to save energy, because energy is so cheap that there's no payback. It would take forever because gas is cheaper than anything you could do in your house. Now this guy understands how to sell a high-performance home. He knows how to deliver the future we want. And for most people in North America, that is the big suburban house with solar shingles on the roof, a big battery pack on the wall, and 2 Teslas in the garage. Because he knows that people don't buy what they need, they buy what they want. And what they want at this stage of their life, when they can afford that, is up at that self-esteem level of Maslow's hierarchy of needs. Recognition and respect. They want it to be seen and known. There was even a survey done a couple of years ago that looked at this issue and found that there were some people who would put solar panels on the shaded sides of their houses so that their costly investments are visible from the street. They called this behavior conspicuous conservation. So this is what they want, a sort of ordinary looking house with visible signs of their investment in the form of solar collectors. Which brings us to the Passivhaus, which I'm a big supporter of, and which is, I think, the best approach to making a high-performance home. But look at what the 5 principles are. Super insulation, high-quality windows, ventilation system with heat recovery, thermal bridge-free and airtight construction. You can't see any of these. You can't show someone the way your wall is built from the outside. They just see the siding. You're certainly never going to be able to show anyone the Intello Smart moisture and air control barrier that's inside the wall. You maybe could, like my friend Ben did here north of London, you could show me your heat recovery ventilator system, which is that key part of air exchange, but most people aren't going to be as impressed as I am with this kind of thing. You don't have handy slices of your high-quality windows out there to show people, because who has that hanging around their house? The only way that you can actually see that a passive house might be a passive house is that they do sometimes look a little bit different. For instance, the north side of the house might not have very big windows, because very good expensive windows still worse than a lousy wall. So you tend to minimize the amount of windows. They're also very expensive. Passive houses also often tend to look a little boxier than normal houses because every corner can be the possibility of a thermal bridge. You've got more surface area, more insulation, so there's a cost factor in it. Now, I've written before on Tree Hugger that buildings can be BBB or boxy, but beautiful, as Bronwyn Berry calls it, if you have a good idea. But what we really have to do is, just as I've also said, start accepting that it's a different kind of aesthetic. Dudley Moore did a movie in the 80s which got picked up by Volvo in their ads saying they're boxy but they're good. And I thought the tagline, "This is not a smart time to be sexy with so many new diseases around," was probably as appropriate today. Now, when I put that Volvo ad up on Twitter on last Saturday night, Dr. Wolfgang Feist, who is the co-founder of the Passivhaus movement and who is head of it today, came back and said, no, they don't have to be boxy. They can be anything you want them to be. And of course, he's absolutely right. You can. Like this building in Vancouver, you can make it twisty and bumpy and bjarky and anything you want if you have the money. But we're talking about building houses that more people can afford, that meet a real need. And right now, that real need is to give more people the opportunity to have a house that is healthy and comfortable. And I think this is going to be the next big obsession about house design. Now, there are people who will sell a lot of add-ons. For instance, the people at Delos behind the Well Standard also sell this equipment that you can add to your house called Darwin that gives you fresh air and purified water and circadian lighting and a good sleep environment. And the New York Times last week had an article about a guy in Florida who's added $300,000 worth of gizmos to his house so that he had all these things. But we're getting into the kind of problems where everybody has to have this. We should address it with real science, and we should make it affordable and accessible to everyone. Now, let's look at the problem that we're facing, or we were at the time I recorded this, which is air quality in the western United States, where all of that red in the sky is coming from particulates. Air pollution. Now, we never used to worry about particulate pollution, the kind particulate matter less than 2.5 microns in diameter before, because we smoked, everybody smoked, and people did silly things like barbecue inside, filling their house with PM 2.5. And there we are, a triple threat. We've got burned hot dogs, we've got a campfire, and we've got cigarettes. I mean, you're just swimming in PM 2.5 there. And these are really, really tiny particles, way smaller than a human hair. They go directly into your body. After you breathe them, they go through the membrane, through the lungs, into the bloodstream, into the heart, and even, they believe, across the brain barrier into your brain. And some studies and doctors say that they have the most impact on our health of almost any pollutant, right up there at the top in terms of disability adjusted life years effect on your life. There isn't even a real standard in the United States. Canada and some other countries have a recommendation that over 24 hours there should not be higher than 25 micrograms per cubic meter in the air. People in Vancouver at the time I was doing this presentation were living and breathing in 143. Passivhaus is an approach that really can help because the house is sealed. As Che, the woman who built this house, the Midori house, said, the tightly sealed enclosure, about 10 times tighter than conventionally built houses, keeps random air from coming in random places. And the heat recovery ventilator provided her with continuous filtered air. Only in the worst days did she have a supplementary filter. But that's anecdotal from her. This January in Australia, there were some real studies done, and they looked at the effect of Passivhaus on air quality inside during a smoke event. Outside, you can see it's up at 600 microns per cubic meter. Inside the red line, which is a conventional house, it's at 500. The passive house is half of what it was, but still higher than it should be. Here you can see what happens when they actually stick a HEPA filter on as well. They drop it from the outside to below the 24-hour threshold of 25, so that a passive house with proper filtration can actually bring the air quality down to acceptable levels. And we don't even know if those are safe levels. We don't know if there's a bottom to PM 2.5 contamination. But this is certainly better than anything else we've seen. Then we have the other problem that's happening, the other tiny particle that's flying around right now, and that's the coronavirus. And the same sort of rules apply. Although it's different in that the coronavirus really travels on micro droplets of moisture. It doesn't sort of travel on its own. And what we have to do is avoid recirculation of these things. So the recommendation is no recirculation and lots of ventilation with fresh air. The trouble is, in most of our homes and most of our buildings in North America, the air system that heats and cools the houses also provides the ventilation. So that if you're in a building with lots of different people, or even if your house, if someone's sick and everybody else isn't, it's quite possible that it goes through the return air and it's all distributed. And the amount of fresh air that you're getting into the home is either random or a really small proportion of the air, because our systems are built on recirculation. The passive house, on the other hand, is designed so that the ventilation system is completely separate from the heating and cooling. So you can have entirely fresh air brought in, while you exhaust all the air from your bathrooms to the outside. And therefore, you always have fresh air delivered through the heat recovery ventilator, where inside air and outside air transfer the heat, but they don't transfer the air. Some people, like the Australians mentioned, are putting HEPA filters on the system. The problem with this is that the HEPA filters really cut down the amount of air that goes through. There's a lot of resistance, so you need to have a more powerful fan, and there's more energy consumption from that. And the Australians suggested only stick in the HEPA filter when you really need to. You also have to be sure that your system actually has the power to push the air through the HEPA filter, which a lot of systems do not. There's another issue that affects where the virus is affected, and that is by humidity. There are studies shown that when the air is dry, people get more infections, and one of the reasons is that the droplets stay in the air. In hydrated air, in moisture air, the droplets fall to the ground much more quickly because of the air essentially being more dense. The problem in normal houses in colder climates is that the humidity in winter gets quite low, because otherwise you get condensation on the windows and possible mold growth on the walls. And so the thing about a passive house is, because the walls are so warm and the windows are such high quality, you can keep the humidity up to between 40 and 60%, which for all kinds of reasons, bacteria, virus, fungi, allergies, everything, respiratory infections, is where you want to be for optimum human health and comfort. So in summary, these are the points that I think that we have to make about high performance houses. And I don't really even mention energy here. I take that just as a given. The first and most important one in today's world, where we're spending so much time inside, is comfort. And when you're in a passive house, the windows and the walls are almost the same temperature as the room. It's a thing I won't go into great detail about, called mean radiant temperature. If the walls are the same temperature as you are, then you feel warm. If the walls are colder than you are, then your body is losing heat to the wall and you feel cold. It's the same thing in reverse. If the wall is hotter than you are, you're going to feel hot. The other thing is security, that a passive house with its thick walls and insulation essentially works as a thermal battery. So if you're in a really cold climate and the electricity or the heat goes out, you can see like this one from the Arctic vortex that it got to like -10 below Fahrenheit outside. And yet the people inside this house, I believe it was in Maine, didn't even turn the heat on until they were 5 days into the vortex because the house, a thermal battery, stayed warm. And if you're in California or somewhere like that, and the electric company turns off the power to save to keep the wires from setting more trees on fire, your house will stay cooler because the thermal battery works both ways. Another benefit is quiet. I was in this passive house in Brooklyn where an ambulance and a bus went right by on the busy street in front. I couldn't hear the bus at all. The ambulance, I could barely hear it. And that's because there's noise reduction, effectively 50% quieter inside a passive house compared to a normal conventional building. And then there's, of course, what I think now is the very big one, the indoor air quality. The fact that the passive house being airtight and having the filtered heat recovery ventilator system means that the indoor air quality is significantly better than the outdoor air quality. It also works as what's being called hygiene ventilation. The passive house could be effective in the fight against COVID-19 because you're having fresh air and no recirculation. When I did this presentation the first time, Dr. Feist made a comment which reiterated these points, but also reminded us that this is a cure against the causes of climate change because the houses are so low in their emissions. They're not adding to the CO2 that's creating this problem. Back to Suzanne Shelton, who did these surveys that I like to talk about all of the time, where she pointed out that the global pandemic of COVID-19 has caused massive shifts in thinking and behaviors globally, causing many of the ideas and actions that were once considered fringe to become prevalent among mainstream Americans. High-performance buildings in general, and passive house in particular, used to be considered fringe. They're not anymore. These days, with the climate and the health challenges that we face, they should be considered standard practice. Thank you.